Hi, my name's Dan, and this video is one in quite a large set of videos which are charting the progress that I'm making creating a simulated 4-bit CPU. And I'm doing it uh, from basic logic gates and discussing the theory and what I'm doing all the way through. So hopefully, if you're following on, first of all, you're making along with me, and you will get the joy of seeing this thing finished at the end. But also, you're hopefully learning something as you start to understand the principles that go into these elements of digital electronics and, in particular, computers. Um, so there's a roadmap of where I'm going with these videos in the description down below. There's also a link to this software, which is Digital Works, which is free software, um, which if you haven't already got hold of, you can get hold of through there. Uh, so the larger plan has been broken down into smaller playlists, each one dealing with a particular aspect of this creation of this 4-bit CPU. We started out quite generic, and we've been creating registers recently, and now we're going to create a memory bank, and this is the culmination of this little set of videos. We had some discussion about what we need for a memory bank, and I will verbally remind you of those things as we go through. And in the last video, we created a double bus register because that's needed for a specific I/O register from the memory bank. So let's start by creating our internal bus for the memory bank, and this is going to be quite big, and we're going to use tag devices, even though we're not going to necessarily connect to them. In fact, no, let's not. Let's use LEDs for both the top and the bottom because it's so. This is going to be quite a long bus. He says, I'm going to start by making it quite short, but you'll see why. And I'm just going to turn that into 4 of those and then stretch these out so they're in a line. I often don't bother with lining these things up because it's not a particular problem um, if I don't need to do any more manipulation of them. But in this case, I'm doing that because particularly I want the bottom, because I want to be able to drag this down. Because we're going to need more space. I'm not quite sure how far I'm going to need to take it. We'll find out as we start putting other elements in. Right. We're also going to need our 2-register bus. So we're going to have that towards the top. And we're going to make it so the instant that I put that in, it becomes obvious that bus A is going to be the internal bus, and bus B is going to be the external bus, which can then connect to other components. And in terms of keeping the wiring as reduced as possible, I'm actually just going to put the pins for bus B right there. And instantly wire them up. There's going to be a lot of wiring to do, but these are ones that could easily be forgotten, so I'm not gonna skimp on that. We've also got value here, and I'm contemplating whether the memory bank as a whole is going to allow you to see the value in that register. I'm not sure. I will come back to that decision. We've got set and clear. These are not hugely important on this register. And the main things that we're going to want in addition to this are we want the address input. So we're going to use tags for that. 2, 3, 4. And let's start some annotations. Let's call it internal bus. And address. Right. We are going to need two 4-bit decoders. I suspect, do we want the enable ones? Yes, we do. And I'm just going to line that up there. 4-bit decoder with enable. So one of these is going to deal with reading, and one of these is going to deal with writing. And so the enable will just be connected to an external pin, which will be read or write. And these will be connected to the read and write of the 16 registers that we're going to use. So I'm now going to put in those 16 registers. So these don't need to be 2-bus registers. In fact, it's better if they're the single bus registers. And I'm going to want 16 of these. I'm only going to use the bus connection, so I'm not going to use the data connection or the value connection on these. All the controls are at the side that I'm going to need. So actually, these can be fairly close to this bus. And because I've been fairly clever about this, they can be quite close together. Let's be doubling these up. That didn't double up, did it? I know it seems wasteful to do that, but I find it easier. And then finally, I sometimes wish I could zoom in and out in DigitalWorks. Control and V, and it's going to take a little bit of shuffling to get these into position. And yes, I'm going to need more space on the. Come on, line up on this bus here. So I could have done this maybe slightly differently by having a bus in the middle and half of them one side and half of them the other side. I actually prefer them this way round because it's less confusing this way. What else am I going to need to wire up? I'm not sure, but I've got a whole load that I already know I need to wire up. I need to wire each of these to the bus in turn and take care that I'm doing that. And I'm going to need to wire up one of these. Let's label them so that one's read and one's write. Let's label them above. Read and writes. This again, it just helps me keep my head clear as to what I'm actually doing. And so there starts to be a little bit of potential confusion when we start talking about memory, because when you talk about writing to memory, actually what the individual register does is it reads from the bus. So write will be connected to the bus read. And read is the other way around. When you want to read from the memory, you actually want the individual register needs to be output enabled. So I'll make sure I do that when I wire it up. It's because read and write are used in slightly different contexts this way. I will need to think about some of the finer points of the wiring, but at this point in time, I am now going to give you a whole shed load of that beautiful music whilst I wire up all these obvious wires. So I'll see you at the other end. So how am I doing so far? I've wired up the bus for all my components. I've wired up all these things out of the decoders. So the read ones I've wired up to the output enable. As I discussed before, it's kind of you need to swap them. And the write is connected to the bus read. That's because we're writing to the memory into this register. So this register needs to read from the bus. For example, you might have noticed a couple of things as I wired this lot up. Is the first that I used a little bit of a trick by putting some tags, dragging them down to the bottom, and then connecting across, and then deleting the tags, which leaves behind the wires with the corners. The second one is that the spacing for these outputs on the decoder could have been better in that these lines aren't exactly vertical, and because of that, as I was connecting them, sometimes they kind of disappear from view for a little bit. What else have we got wired up? We've got bus B wired up there, and we want to wire up uh, a bus read and output enable for that output data register. So we'll just connect those in there. What do I want in here and here? So we want a read command. So I'm going to create tags for both read and for write. So read, I'm going to put right over here because it's near the right decoder. I'm going to label those read. That tag's a bit close. And write. Actually, no, I'm going to put them, the tag, over here. I'm going to put them closer together. And there's a little bit of a trick to this because, and the reason why I've put this over to the left here and not just directly above the enables for here is that although write does need to go to that enable there, everything's getting a little bit crowded at the top here, so I'm just going to do Control C to select all and use the arrow keys to Control C to select all. Control C to select all. And then slide down using the no. Why is it not selecting all? Control? No, Control A to select all. That's better. And just slide the whole lot down a bit to give me a little bit of space up at the top here. Move the read and write slightly higher. Right, so, and they're crossed over. Let's turn them around. Does it matter? Right, read. Starting to get a little bit obsessive about positioning. So I'm going to connect across there to the enable. So what that's going to do is when it hits the enable, that then gives me a bus read. But what I also want to do when I'm writing is that I want to output enable for the data register. So when write is hit, the data register determines what's on the internal bus, and the address that's coming in here tells us which of these registers is going to use it, and then it goes through the enable so that then it will do a bus read, and so it will read into the correct register. And we want the opposite effect for the read command, which is that we want to take the contents of the memory location and put it into the data register, so the IO data register. So we're going to enable on this one, which then gives us output enable for the correct uh, memory location. And so we need to bus read. Let's do a little bit of a jiggle. There. Okay. One last thing that I haven't created yet to connect up is a clear line. So it's just a command that's going to clear everything. So I'm just going to stick in um, a line to do that, which is going to connect all these registers and the clear. There's a few of those to do, so it is worth me fast forwarding and giving you some um, music as we do that. Right, so let's do a bit of a visual check through what we've got. Um, First of all, let's have a look at the components and whether they've got things attached that should be. So these two decoders, we've got an input, we've got an enable, and we've got all the outputs wired up, so that's fine. Our dual bus, so our I/O register, connects to the internal bus and has got the bus read and the output enable are being used by the read and write. And then it will have a separate bus read and output enable, which is going to form part of the outer package for the data for the memory bank. We've got a clear, and we've got bus B there, and I guess it does no harm to stick some tags here to allow us to inspect what's going on. So let's have those. They're going to be value tags, which will appear on the template. And for the individual registers, each one needs a bus read and an output enable and a clear. But we're not going to use the data read or the set. We don't need the data lines or the value lines, so none of those has been connected. So we need to check that we've got 4 down this side, and then 1, 2, gap, 1 down that side. Let's check all of those. So that's the first one. 4, 1, 2, gap, 1, 4, same pattern, 4, same pattern. Where are we up to? Who knows? 4, same pattern, 4, same pattern. Same pattern, 4, same pattern, 4, same pattern. To be honest, at this stage, we should also be checking those are lined up as a kind of a diagonal line. So let's quickly check the higher ones as well. And in fact, we can do this quite quickly, zooming down here, checking those because they will be 4 across. The clears are all connected to the clears. You can't see me running my finger up along there on the screen. And I've got read going to the far side and OE coming to the near side. And again, I'm just checking that all of them have those two connections. And I'm kind of looking at this bit around here and the fact that that crosses over as being the indication that they're wired right. Let's check what inputs and outputs we've got. The internal bus shouldn't have any connections in or out because that's just for internal use. We've got an external bus connection there. We've got a bus read and output enable. We've got the value connections there we're going to be able to access. Importantly, the address comes in, and then these commands read and write and clear. So I think that's everything we need. The number of tags we've got to connect up to the template is actually not that many, because with a memory bank like this, the important stuff is the internal complexity, and actually it's starting to become less complex externally in some ways. So let's. This is a 4-bit memory bank. Okay. And we're going to, once again, the bus is going to be on the left-hand side here. So let's just edit that annotation and call it bus 3 to 0. I'll take that off. We are going to need a bus read and an output enable that's related to the bus. So let's potentially keep those there. We don't want to set, but we do want to clear. So I'm going to get rid of that one. That's actually got both of those on that annotation. So this is where I found that that wasn't the best idea. And I guess I could question which would it be better to have the address at the top. But actually what I'm going to do is I'm going to check the address in at the right-hand side. So let's edit that annotation and say that's the address. Move these two out of the way a bit. We've got a value, and that's fine because we're going to want 4 values coming out. And the final things we're going to want here are a read and a write command. So a read, right, let's keep that as one annotation. And our 2 pins there are going to do that for us. Kind of just checking my head again. So we've got 4 pins there for the bus, 4 pins there for the bus, output enable, and bus read. That's fine. We've got 3 commands: read, write, and clear. Clear, read, write. So we've got an address input, which is going to be here, and we've got a value output over here. So I'm going to go back to, yet again, the music as I fast forward, as I wire that up. Okay, here we go. Right, there we are. I hope you've been playing along with me and that you've managed to wire all this up as well and connect the pins to the tags from the template. And before we go to testing phase for this, I'm just going to do a quick sanity check on one particular aspect, which is to do with the addresses that are coming in, which is that we've got the 16 registers in a nice column on the left-hand side there. And in a sense, it doesn't matter which register is given which address, as long as it's consistent. So as long as the same address works for writing and reading. So if you have the same address, you would access the same element, then that could all be jiggled up and it doesn't matter. So the 2 elements that I need to check for that is that the outputs from both decoders are ordered in the same way. So we've got the left-hand one going to the top, the left-hand going to the top, and so on down, and that's fine. And then the other one is to absolutely double-check that the address input is going to the same, going in the same way. So this is left-handed is address 3, and it's going to there for 3 and there for 3. And I'll check the other end, 0 for 0 there, and 0 there. So it should be correct in that sense. So I'm going to save this circuit. Excuse my cold. And this is a memory bank 4-bit. Okay, that should have appeared down here. There we go. I was feeling a little bit trepidatious doing this, going new circuit and getting rid of all this, but it has been saved. Um, so I'm going to pull in a memory bank and test it. So crazy it seems in some ways that this thing with 4, 8, 12, 13, 14, 15, 16, 17 pins only, which doesn't, it seems like a lot maybe, but compared with when I double click that, the complexity of what's going on underneath the hood here, actually there's much less to do at this level. So I am going to stick in a bus, and I'm going to stick in some inputs and outputs, and this will again take me a few minutes to set up, and I'm getting to the stage where I'm kind of obsessed with giving you this music. So um, enjoy. We'll fast forward. Right, here we are. We're all wired up and hopefully ready for testing. Let's turn the simulation on. I found this is quite an exciting phase because I think that memory bank's a fairly sophisticated piece of circuitry in some ways. It's going to feel like there's some magic going on behind the scenes. So we turn on the simulation immediately. We've got 1111 in there. This has been a consistent theme through these videos that our memory circuits seem to set themselves to that. So the first thing we're going to do is to try a full clear. To hit that. That should have cleared everything in the memory bank. It's kind of hard for us to know because the only way we can find out what's going on in the memory bank is by sticking an address and doing a read. So, well, in fact, let's use address 0000, and we're going to read from there, and whatever's in there should appear now in our value. But it's 0. And that's how it should be because we've just cleared. Right, let's stick a value in. So let's use 10, which is 1010, and then we're going to enable that to that. And we're so this is 2 phases that we need to do this to actually do reading and writing from memory. So the first one is to take the value from the external bus and put it in the I/O register. So we do a bus read to do that. And so now we've got this value here. We can abandon this if we want as this goes on. And we're going to put this into address 0000 at the top of our memory bank. Why not? And so we're going to do a write. Right, there we go. Let's change the address, and this is, let's go to 0001, and let's do a read and see what we've got in that address. We should have zeros, and that's fine. Let's go back to 0000 and read again, and that should give us the 10. Yes, it's there, right. Let's write to address 0001 then next. So let's stick a value on our bus to be able to do that. I'm going to use 01111, 0111, yes, which is 7 in decimal. So again, 2 phases. We need to read from the bus, which puts that into this I/O register, and then we're going to be writing, and we're going to put it into address 0001. Write the memory. There we go. So let's go back to 0000 and read that from the memory, and that should be 10. So that's 10 as we had previously. And let's at this point check the output enabled to the bus. So let's disable that one. And it becomes a lot more pain when testing this if we're not careful to do that disabling, because stopping the simulation will get rid of the values that we've got in the memory. So output enable 10. There we go. And we're going to go to location 0001, and we're going to do a read from there as well. And that's the 7 that we put in earlier. And then if we do output enable, that puts the 7 on the bus. Okay, so we've only checked 2 out of the 16 memory locations. I guess it would be sensible to check the final one as 1111. So let's once again make sure our output enable's disconnected there. I'll have a value here. Let's have the value 12, which is 1100. Let's pull that on the bus, and then we're going to bus read to get it into our register, IO register. And then what address did we want? We're going to put it at the very bottom. So what do we want to do? We're going to write to that address. There we go. Hopefully, let's go back and read from 0001, which should still be the 7 that we had. Read, yes, we got the 7. And let's then go back and read from 1111, which should be our 12. And there we go. So, as I said, I haven't checked all values and I haven't checked all memory locations. It would be possible to set up an automated thing to test this if you have the actual physical electronics. But it would appear that our 4-bit memory bank is working perfectly as we want it to. Have we checked everything? We've done bus read and output enable over here. We've done the bus connectivity. The values seem to be working. We've used a clear. Let's use another clear just to check that. We've done reading and writing, so let's do a final clear. And that should have cleared all the memory locations. Let's read from 1111, and it is 0. Let's read from what we previously wrote, 0001. Read. That's also zeros, and our top memory location, 0000. Read is once again 0. So I think, yes, we have reasonably proved that our memory bank is working. So that is it from me for now.